Corporate finance practice problem using OneNote. Acquisition, expected value, standard deviation, and coefficient of variation. Get ready, it's time to take our chance with corporate finance. Here we are in OneNote. If you have access to OneNote, would like to follow along, you're not required to, but if would like to, we're in the icon left-hand side, the Practice Problems tab, down in the 2022 Acquisition, Expected Value, Standard Deviation, and Coefficient of Variation tab. Also note, when using OneNote, look at the Immersive Reader tool. Our presentations will also be in the text area, same name, same number, but with transcripts that can be translated into multiple different languages and either listened to or read in them. Closing the icon, we got our information up top, calculations on down below. We're looking at an acquisition type of situation. Going to be calculating our expected value, the standard deviation, and coefficient of variation. These are kind of statistical type of terms we looked at in a prior section. So if you want to see more problems like this in more detail, look at that section. We're going to apply the concepts learned there to a situation here where we have an acquisition type of situation. So we're going to imagine C company is thinking about two merger possibilities with company A, which is in its own industry, which is a volatile industry, and company B is in an industry which moves in the opposite direction, having negative correlation. So note what we'll be comparing and contrasting in these two different kind of merger types of situations would be the fact that if we merge with somebody that's within our industry, then that could increase our gains when things are good and our industry is operating well. But if we're in a volatile industry and those circumstances when the market isn't good for us, the downturns, it can also increase the downturns or the dips that could be involved as well. Whereas on the other hand, if we were to merge with a company that was negatively correlated, that might cause us some problems because they may not be exactly doing what we do. So, there could be pros and cons as you do the merger, but it may smooth out basically the downturns in a similar way as you might have like a diversified type of portfolio so that when the times are good for one company, maybe not so good for the other company and vice versa, that would kind of even out the downturns. So the things that we would want to be looking at then would be, okay, well, what's going to be the impact basically in the overall growth potential, the earning potential, and possibly from a shareholder perspective, the earnings per share, which one would be expected to be a higher earnings per share? And then, given that information, taking into consideration kind of the volatility type of thing, which would be involved between these two. We would expect the volatility, the deviation from the mean or the average or the earnings per share that we're projecting to be higher for A, given the fact that you're in the same industry, which is volatile, than B. But you could also have a trade-off there where you'd have higher earnings per share increase in the revenue in that situation. So those are the trade-offs that we would have, common kind of trade-offs, the potential earnings versus the added risk involved with it. So let's imagine company A. We're going to do our estimating type of scenario here that we talked about once again in a prior section, estimating the earnings per share, and we're going to try to figure out a statistical kind of way to think about this, picking up three possible outcomes and then trying to think about what the probability for those three outcomes would be so that we can basically apply a statistical approach to our decision-making process. So we're going to imagine with company A, the estimated earnings are going to be 60 or 75 or 90. So we can imagine a situation where we think, well, if it goes not so good, 60. If it goes well or average or maybe what we expect, 75. And if it goes better than we expect like 90. And then we're going to say, okay, well, what are the probabilities that we think this is actually going to happen? We're going to say maybe 60 is 20% versus the 75 is at the 60%, the 90 is 20%. And these percentages, of course, have to add up to 100, 60, 40, 60, 20, 20, add up to 100%. Then we can apply kind of our statistical kind of analysis. First step being, well, what would then be our expected value that we would expect given these percentages, which we can calculate by simply taking the 60, 75, and 90, same numbers here, picking up our rates at the 20%. 20% of 60 would be the $12. And then we're going to pick up the 60%. 60% of 75 would be the 45, and then the 90 and 20. So 90 times the 20% would then be our $18, the 12, the 45, and the 18, adding up then to the $75. So given our scenario over here, we could do this kind of average type of system, expected value similar to the average or the mean when we do our statistical analysis, getting to an average of that 75. So from a statistical kind of standpoint, you're kind of imagining that if you're looking at a graph or something, that's basically your middle point, kind of the average point. And then we want to apply out, well, what would be the calculations to help us with the variation, which could then be helping us with the calculation of risk that would be involved. So we're thinking terms like standard deviation, which would be saying how spread out is the data from what we're imagining, kind of like that central point to be. The more spread out the data is, the more likely we won't be at the central point and possibly underneath it, which could be bad, right? That would be more risk that could be involved here. So that's going to be the general idea. We'll start off with the same points here. We got the 60, 75, and 90, and then we're going to subtract out. This is to get basically to the standard deviation kind of calculation here. We're going to subtract out then the average, which is the expected value or the mean, you might call it. That'll give us the difference. So 60 minus 75 is negative 15. 75 minus the 75 average, 75 minus the 75 is 0. And then the 90 up top here minus the average 75, once again, is going to be the positive 15. Now, this negative and positive business doesn't really help us because we're really kind of trying to see what the spread is from the central point, like the mean. So we're going to square it, which will remove the negatives, and it'll actually amplify these differences as well. So if I take the 15 squared, do that with a trusty calculator here. When you do these problems, make sure that you do have a calculator that can have the square button. So we got the square button here, so we can use that. That's going to be the 15. I could say 15, make it a negative, and then square it. That would give us the 225 positive, of course, the 0, and then the 15 squared. If it was positive, we got 15 squared, once again, the 225, okay? Then we've got the probabilities we're going to pull over, which is going to be the probabilities, once again, of the 20, 60, 20, 20, 60, 20 up top, 20, 60, 20. So the 225 times the 20% is going to give us the 45. The 0 times the 60% will give us 0. And the 225 times the 20% will once again give us the 45. Adding up the outer column, 45 and 45, gives us the variance of 90. And that's including the squared numbers, though. So now we want to take the standard deviation and we'll take the square root of that 90. So once again, make sure you got a calculator where you could take the square root. So we're going to say, all right, what if we got the 90 here and we take the square root? That's going to give us the 9.49 about. And then that's the standard deviation, which could be useful, but when we're comparing to another item, we're often looking for that coefficient number, coefficient of variation. So we're going to take the expected value to get to the coefficient of variation, the expected value once again being the 70 we calculated up top. We're going to take that standard deviation and divide it by 70, giving us the 0.12649, so on. That'll give us our coefficient of variation, which will make sense when we compare it to another item, which we'll do shortly, to see whichever one is lower. That would give us the less spread that we would expect and the less risk we would expect. So let's do the same thing for B. If they merge with company B, we're going to say, well, what would happen then? And we're going to imagine the estimated earnings are the same here, the 60, the 75, the 90, but the probabilities are going to differ with B, meaning 80% at or 10% at the 60, we think it's more likely that we're going to hit that 75 probability, and then the 90 at the 10% again. So same estimated earnings, different probabilities, resulting in the 60, 75, 90, and then the 10, the 80, and the 10, and then we just multiply that across. The 60 times the 10% would be 6, 75 times 80%, 60, the 90 times the 10%, 9, the 69 and 6 giving us once again 75. So we get to that same 75 number, which is the expected value, same number we got up top. So when we're looking at these two options and we say, well, what do we think is going to happen based on our analysis? We have the same expected value between the two. So just based on that, we would say, well, it wouldn't matter if we would merge with A or B. So then we would have to default to the next thing and say, well, how volatile would it be for us to merge with one or the other if that is the same. So those are the two things we would, of course, want to consider. What's the likelihood of our expected value that we would have? And then if one was higher than the other, then the question is, is there going to be more volatility between the two? So if, for example, the expected value was higher and the volatility was higher, then the added volatility might be okay, given the fact that our expected return was higher, and so on. These two have the same expected return, so you would think then we would pick the one that has the less volatility between the two, which we would expect to be B, since they're negatively coefficient industry. So let's take a look at it. So then we're going to say the probabilities are going to be the 60, 75, and the 90. The expected value is going to be 75, which we picked up top. We get the standard deviation and the variance and whatnot by taking the difference between each point and the expected value. This is our statistical type of analysis. The 60 minus 75, negative 15, 75 minus 75, or 0. 90 minus 75 is 15. We're then going to square them just as we did before. That gives us the 75 minus 15, the 225. The 15 squared gives us the 225. 0 squared gives us 0. 15 squared gives us 225. And then we'll pick up our probabilities, that being this time the 10-80-10 versus the 20-60-20. So 10-80-10 on the probabilities, we got the 225 times 10%, 22.5. The 0 times 80%, or 0, and then the 225 times the 10%, once again at the 22.5. The 22.5 and the 22.5 giving us the 45 for the variance, and then we'll take the square root of that. So we're going to take that square root. Let's do that in the trusty calculator. Making sure you got the calculator with the square root button. 45 square rooted, 6.71 about. 6.71 about. And then we got the expected value at the 75. So if we take that 6.71 divided by 75, we're going to get the 0.089 and so on, 0.08944. Now that variance is going to be less than, this coefficient of variation up top, which would mean that we would expect it to then have less movement from the center point, which we would expect to translate into less risk that would be involved. So given the things that are involved here, if we have the same expected return, 75 and 75, and B has the smaller coefficient of variation indicating that it might be less risky, then we might go under this analysis with option 2, company B merger.